Well, good night. Today we are going to be talking about unsupervised machine learning. Here I have a sum up of everything I have investigated in today. I'm not going to read it all, so I'm just going to read the parameters and what unsupervised machine learning is about. But first, it trains algorithms on labeled data to discover hidden patterns, structures, and relationships without verifying outputs or human intervention. It's totally opposite to the supervised machine learning algorithms because humans have no power on what happens in the algorithm. It works with unlabeled data. It has it on some algorithms you would have to say if you need current or something that's happening here. It discovers a pattern on its own and its structure is inferred. So three models are going to be talked about in this video. The first is FUCC means, Gaussian mixture models, and self-organizing maps. The first one is FUCC means. As you can see in the screen, to begin this method, we need a dataset. The dataset is a two-column uh, with different numbers, and we first upload the dataset. Then, with the function center, we perform fuzzy clustering. The variable u contains these membership values, and then the code finds which points have the highest membership in this cluster with max u and find. The script plots two clusters in different colors, blue and red, and marks their centers with X symbols. This gives visual presentation of how the algorithm divides the data in soft boundaries rather than hard ones. So in summary, this first script, it demonstrates soft clustering where boundaries are graded and overlapping. The second method is the Gaussian mixture model. This is a technique based on probability and statistics. For this method, we are going to use the famous Fisher-Ayres dataset, but we only are going to use only two features. In this case, the variable sigma defines different types of convenience matrix, diagonal and full. For this dataset, we are going to use a k value of 3. This is the number of clusters that are going to be used. Then we use the Mahalanobis distance to calculate how far each point is from each cluster and plots the ellipses representing 99% confidence boundaries. As we can see in the code, in the graphs, that's what it does. In the second part of this code, you can see the script tries to initialization methods for algorithm in different conditions, and it demonstrates how Gaussian mixture models use probability to identify clusters with more flexible and realistic shapes. The last method is self-organizing map, SON. It uses the neural network approach called self-organizing map to build, and we used a simple dataset called simple cluster dataset, which is within MATLAB. What it does, it creates two-dimensional grid of neurons, specifically an 8x8 network using 64 variables. Each neuron represents a node that we learn to represent a group of data joins, just as we see in the graph. Then we have to train that neural network, and it organizes itself into similar data points which activate nearby neurons, effectively mapping high dimensional into a 2D space. After training the command, ViewNet displays a graphical map showing how neurons are distributed and connected. Finally, each input to a neuron effectively classifying the data. This method is used for data visualization. To sum up, these three scripts or methods I've just shown are complementary ways to understand and visualize the natural grouping patterns in data. Thank you for listening.